Hello everyone, this is your tutor AB and today we're going to be solving a problem from the November 2020 IB examinations. This is a math AHL question and it's worth 15 marks. This is an additional higher level problem and it's a paper 1 question. So let's get started. They're asking us to consider the curve C defined by y square is equal to sine xy, where y is not equal to 0. Show that dy by dx is equal to y cos of xy, the whole thing, divided by 2y minus x cos xy. Let's do part A and then we'll look at part B and C. Let's do one by one. So part A, how do we solve it now? So they're asking us to differentiate. They're saying dy by dx, so we need to differentiate our expression. So let's write down our original expression. Y square is equal to sine of xy. So let's differentiate. This is going to be an implicit differentiation, so make sure you know that skill before you approach this question. So let's differentiate both sides. So d by dx of y square is equal to d by dx of the sine of xy. Okay, so we have to differentiate left and differentiate right. So it's an implicit differentiation. On the left it just becomes 2y dy by dx. That's what happens on the right left. And then on the right we need to differentiate sine of xy, and this follows a chain rule. When you differentiate trigonometric functions such as sine, first you differentiate the outside part, so sine xy becomes cos xy, and then you follow it up with the chain rule, so you differentiate the thing on the inside, which is xy, right? You need to differentiate xy, but in this case, right, it's a product rule because there's two things multiplied with each other. So I'll just say here, apply product rule. You need to apply a product rule when you differentiate xy, so we can keep x, differentiate y, would just become dy by dx. Alright, let's just put this in a bracket, plus you then differentiate x, so that just becomes 1, and you hold y, which just stays as y. That's how it looks. So 2y dy by dx is equal to cos xy times by dy by dx x plus y. Okay, we of course need to solve for dy by dx. Here we are not solving for dy by dx, we have it on both sides, so we need to group our like terms together. So how do we do this? Well, let's expand the right side. So 2y dy by dx is equal to, let's expand it, so we get dy by dx x times cosine xy plus y cosine xy. Okay, now let's bring the dy by dx to the same side, so we get 2y dy by dx minus dy by dx of x cosine xy is equal to y cos xy. This is just algebraic manipulation. I'm bringing this whole term to the left, this whole term goes to the other side, subtract it from both sides. So then what can we do now? We need to get dy by dx alone, we need to isolate it, so let's factor it out of these expressions. So we get dy by dx, you get 2y minus x cos of xy is equal to y cos xy. So let's divide it both sides, so we get dy by dx finally is equal to y cos xy over 2y minus x cos xy. So let's check, have we proved what we need to prove? Y cos xy, 2y minus x cos xy. So we've proved the first part. Dy by dx is indeed equal to this expression. Okay, that's part A. And this is a 5 marks. So this is 5 marks. Each question in this problem is worth 5 marks. So let's do part B, which is also worth 5 marks. So let's just write it there. Another 5 marks. This is a total 15 mark problem. So it's a good chunk of your paper. So what is part B asking? Prove that when dy by dx is equal to 0, y is equal to plus or minus 1. Okay, let's prove this. We already know what dy by dx is, so we need to set it to 0. That's our first step. So let's set this dy by dx to 0. So y cos of xy over 2y minus x cos of xy, this whole thing is equal to 0. Okay, so what can we do here? Let's just bring the denominator to the other side. Let's multiply it both sides. So we just get that y cos xy is equal to 0. It's just simply cancel out the denominator because you're bringing it to the other side. Now what can you do? As you know that y is not equal to 0, you can divide the y on both sides to simply get cos of xy is equal to 0. But how does this help us, right? Can we isolate the y here? Not really. But I want you to read the question carefully. Remember this expression, sine of xy? We know the original curve is y square is equal to sine of xy. And we know that's equal to y square. Can I make cos of xy look like sine of xy? Well, yes I can. If I square cos of xy, you must know this equation. Cos square of x is equal to 1 minus sine square of x, right? This is a formula. This is a formula that's actually given in your data booklets. So can I use this in the actual question? Well, why not? In this case, I can say that cos of xy whole square, which I know is just 0, is equal to 1 minus sine square of xy. Or let me keep it consistent, sine of xy, like that. So whole square. Okay, so what do I know? I know that cos of xy is just 0, so 0 square is 0. 0 is equal to 1 minus sine of xy. Let me just keep the language consistent. Sine of xy whole square. So I know that sine of xy whole square negative is equal to negative 1. Negatives and negatives cancel. So we get finally that sine of xy is equal to root of 1 plus or minus. Okay, we get sine of xy is equal to the root of 1 plus or minus. Now, if you take a look back at the original equation, we know that sine of xy is also equal to y square. So let's just substitute that in. Instead of sine of xy, we can write it as y square is equal to plus or minus the root of 1. So y must be equal to, again, plus or minus 1. Okay, now finally part C, which is again worth another 5 marks. So far we've gotten 10 out of the 15 marks for this question. So what is part C? Hence find the coordinates of all points on C for 0, x is greater than 0 but less than 4 pi, where dy by dx is equal to 0. Okay, so what do we do here? Well, it is simple. It's just this is the easier 5 marks of both questions that we've done so far. All we need to do is do basic substitution and find out the coordinates. We know the equation y square is equal to the sine of xy. We know that equation. Okay, so what do we do? Well, all we have to do is say, let's substitute. We know y can be either plus or minus 1. So for when y is equal to 1, x is equal to what? When y is equal to negative 1, x is equal to what, right? This will give us all the coordinates. So let's do that. Let's substitute 1 into the equation for y. So 1 is equal to sine of, and then x. So sine inverse of 1, or arc sine is equal, sine inverse of, sorry, not x, sine inverse of 1 is equal to x. So what can sine be, or what can this x be? Well, if you think about the unit circle, right, sine is positive 1 only on the y-axis, and in this case this would be pi over 2, and we have an interval up to 4 pi, right? So we need the next what's it called, the next rotation afterwards as well. So pi over 2, but also 5 pi over 2 can also work. 2 pi plus 2 pi would all give us 5 pi over 2, which falls within our interval. So x can be, in this case, 5 pi over 2 or pi over 2. Okay, so our first two coordinates are pi over 2 comma 1 and 5 pi over 2 comma 1. That's our first set of coordinates. And for when y is equal to negative 1, okay, when it's negative 1 square is 1 still, you get sine of, well, negative x. And when is, and we can take sine inverse, of course, so we can take sine inverse of 1 gives us a negative. When does the sine inverse, or what angle gives us a negative number? Well, it's going to always be in this bottom area, the bottom y-axis, right, in the negative side. Whenever it lands on this bottom part of the y-axis, it's going to give us a negative. And we know that this is 3 pi over 2, but we have an interval of up to 4 pi, so we can take another plus 2 pi, so another full rotation, which is plus 2 pi. So it can also be 7 pi over 2. That could also work within this interval. So x can be equal to, in this case, 3 pi over 2 and 7 pi over 2. So our set of coordinates are, let me just lasso this. Our final set of coordinates are then 3 pi over 2 comma negative 1 and 7 pi over 2 comma negative 1. These are our 4 coordinates which answer our question. Thank you for watching. Please do like and subscribe, and I'll see you in the next video.